So welcome everybody. I appreciate you joining us today. As I had mentioned, close to 50 people or more had signed up for today's presentation. And as usual, we have about a 50% attendance rate, but we usually get a lot of people who ask for copies of the presentation. For those of you who know, I usually do, if you're part of the my LinkedIn thing, then I usually post my presentations after that, or if anybody wants a copy, or we will send everybody a copy of the presentation. Also, I'll mention that today's presentation through CAI has been approved for a continuing education unit, so CEUs, but you're going to have to send an email to either me or Jody, who you see on the screen from Kipcon, and we'll send you the certificate for continuing education units. Today's presentation is really a big topic, and it has to do with structural evaluations of buildings. Now, I think most people here are from New Jersey, although I do see somebody here from Brooklyn and somebody here from Florida. But everybody in the country these days is involved and interested in structural evaluations and the structural integrity of their buildings. So what, as you know, we've done is we've given a number of webinars on the topic of what the legislation is that's going on around the world, what the CAI public policy is, how this doesn't just affect community associations, because most people here are in the community association industry, because we work on a lot of projects that are not community association based. It's based on buildings, the problems we're seeing. The other thing is we've had a number of managers and people call us and ask us for proposals to do structural evaluations of their buildings. And a manager saying, give me a structural evaluation proposal, but there's really never an RFP of exactly what anybody's looking for and what they want to have included in that evaluation. So what I've done today is I've put together a presentation of what are the different types of evaluations, what's included in them, what do they look like, and some examples from some actual pages of evaluations. Then the last couple slides are also some information in order for you to use when you're putting together an RFP or a request for a proposal for an engineer to do a structural evaluation of your building or buildings. I will tell you also, I've had the opportunity to see examples of evaluations that have been done, and it's pretty clear in the industry that there is there's an evolution taking place in terms of what's required and how to do it. So that's essentially what this presentation is about. And as always, if anybody has any questions or comments, please feel free to put them in the chat box, or actually unmute yourself and feel free to jump in. I'm not shy if it's something I'm going to cover. And Jody from my office will be monitoring the chat box because, to be quite honest, the way it's set up, I can't see it. So that's what we're going to do. Just to give you a little information in regards to my background, so you'll see that maybe I kind of know what I'm talking about when it comes to this stuff. I've been involved in this ever since the tragedy that took place in Florida. When CAI put together immediately after that a task force nationwide, there were about 600 people on it from across the country. And I was one of the co-chairs of the task force that developed a booklet, which I'm going to show you in a second, called Condominium Safety Public Policy Report. I was the only engineer involved in that. And that legislative guide has been used by a number of states to put together legislation in their states for monitoring their buildings. For example, right now in New Jersey, there is a bill pending in regards to public or safety of buildings. And I was very involved with CAI New Jersey on their Legislative Action Committee, also working with Senator Singleton, who was awesome in terms of putting together this legislation, which is in the process right now. I was recently asked to serve on the Newcastle, Delaware Council of Condominium and Interest Community Task Force, which is, I'm co-chairing that. And we're in the process of coming up with some legislative initiatives in Delaware in regards to this. And there's a number of other states. I've spoken to people in Virginia. In Florida, you probably know that there is some laws that have been put into place based on this. But so I've been pretty involved in this in many different ways. What I'm going to be talking about today is the primary pillar of structural safety. In my prior webinars, I've talked about the fact that in order to keep your building safe, that there's really three parts to it. There's the periodic inspections and structural evaluations. There's maintenance and reserve studies and funding. Now, I'll touch on that really with just one slide, the connection of all these things together. But today, I'm primarily focusing on periodic inspections and structural evaluations, so everybody hopefully will understand what they are and what they should look like when you get them, and how to ask somebody to give you a proposal for them. So first, let me give you a little background, which I've actually started on already. As a result of the tragedy in Florida, CAI put together this Condominium Safety Public Policy Report. You can get a copy of this on CAI's website. That's the link, or all you have to do is email us and we'd be happy to send you a copy. But in this, there's a very specific guidelines in terms of, what things should be done. For example, you see the title says reserve studies and funding, maintenance and structural integrity. So it talks about all of these, but it doesn't go into the type of detail that I'm going to go into today in regards to the structural integrity. I will point out that it says reserve studies and funding, because I always like to mention the fact that in many states across the country, they have requirements for reserve studies, but they don't have requirements for you to fund them. And in other states, they have requirements for funding, but they don't say what it's based on, for example, a reserve study. But that's changing. There's a lot of states now that are coming out with legislation in regards to reserve studies and funding based on the accident. But it's also important to keep in mind that because you do a reserve study, doesn't mean it's giving you the safety things you need to protect the structures you're building, which I'll touch on briefly also as part of this presentation. There's a current standard that's used across the country. It's put out by the American Society of Civil Engineers, and it's called Guideline for Structural Condition Assessment of I don't think that is not supposed to be there, sorry, of existing buildings. And this is a national standard that people use for providing assessments of existing buildings. The presentation I'm giving you is based on this. There's a huge amount of information in here, but in terms of what we are doing, that's what my presentation is about. So just about any section here where I talk about something, I can give you a specific reference into this standard of where it comes from. At the end of the presentation, I'll mention another couple of standards that are out there, but this is the primary one in this country. I will tell you also that a number of months ago, I spoke to the person who heads up the standards division of ASCE, and they are in the process of putting together a more user-friendly guide. At least that's what I was told a few months ago, that can be used for the kind of things we're talking about. So we can anticipate that this standard may be updated, but there's going to be a more practical guide prepared based on what the types of things I'm going to talk about. As part of the research and putting together that public policy paper for CAI, we did a lot of research around the world and the United States to see what other countries and other states do. So, for example, in the United States, there's really only 3 places where there are structural requirements for inspection of existing buildings. One is in California, but it's really just for wood decks where they had a collapse. The other is for 2 counties in Florida, where, if I'm not mistaken, the original guidelines were that the first inspection had to take place after 40 years, which clearly is too late. When you look around the world, there are some places where they have very specific guidelines for exactly what we're talking about that we used as part of our reference. Also, one is Ontario, Canada, where they have a structural condition assessment of existing buildings standard. The reason that that was developed in Ontario was because about 20 years ago, if I'm not mistaken, there was a building that collapsed, and this was a result of it. They do require that for community associations, every 6 years, as part of a reserve study, that a structural evaluation has to be done. That doesn't mean it is the reserve study, but as part of a reserve study, another consultant or somebody with the qualifications needs to do it. The other one you see below is in Singapore. Singapore has very specific guidelines for doing structural safety inspections of buildings, where, if I'm not mistaken, their inspection criteria is every 10 years. But if anybody would like to have copies of these, I can also provide you copies. So we did look, like I said, around the world. We looked at Madrid, Spain. They have something every 50 years. So there's all kinds of things, but it's really the first time in this country that people are really taking a serious look at this in terms of what do we do and what are the standards. Thing to keep in mind that, as for all of our understanding, that although all buildings are covered by what I'm going to talk about, in our industry, we focus on multifamily residential buildings. So that's, if you see any slant of my presentation towards that, there's an obvious reason for it. But keep in mind that a building is a building. It doesn't know if it's a community association. It doesn't know if it's an office building. It doesn't know what it is. but the structure is what determines how it deteriorates. So the general requirements for inspections are that it's based on buildings of concrete, load-bearing masonry, steel, or hybrid structural systems such as heavy timber, including podium decks. Now, I'll get into each one of these in a second just to give you an idea what I'm talking about, but you have to keep in mind, it's very important, that the need for the inspections and the evaluation are based on the materials used for the building, not based on the height of the building. There's a misperception out there that it only deals with high rises, but that's not true. I've seen many buildings made out of these materials that are not high rises. And I don't remember exactly, but if I'm not mistaken, the definition of a high rise is about 100. If I'm not mistaken, I'd have to look it up in the code. It's a 175-foot or higher building. So clearly, there's no question from our experience that this occurs with all buildings. It's based on the material of construction, not the height of the building. So I put a key point on there. So don't forget that, because in some places they're still thinking that it's based on the height, not the material. What is the building structure? I'm going to give you a bunch of basic information on stuff to use as part of the detailed presentation. But a building structure is pretty straightforward. It's what holds the building up. So in a building, and you see that I have a high rise on the left and a low rise on the right, just to keep us on track that it's not just for high rise. But building structure is what holds the buildings up. It's made of the columns, the beams, and the foundations. So that is what the building structure is. What is it designed for? It's designed for what's called dead, live, and snow loads. So a dead load is the weight of the building. A live load is the weight of the people and the furniture in the building. And the snow load is the weight of snow on the top of the building. What else is it designed for? Those are what I'll call vertical loads. It's also designed for horizontal loads like wind and seismic, which is earthquake, horizontally. So that's what the structure is designed for. I mean, different parts of the world, there may be other things in the code that need to be included, or different types of buildings, other things that need to be included. But as a general rule of thumb, these are the things that are based on the building code. The building should be designed for the structure. There's a structural system. The structural system, and what I've got up there on the right, comes directly from ASCE. It's an assemblage of structural components within a building that by contiguous interconnection form a path by which external or internal forces applied to the building are delivered to the ground. It's I guess, not the best wording in my mind to use, but what it is essentially saying, it's how the wind loads, the dead loads, the live loads, and the snow loads, and all the loads are carried through the building into the ground. So, for example, I'm showing these diagrams to the left that the dead live load, snow load are vertical loads that are taken to the ground in the red lines. The wind and seismic are horizontal, and they go horizontally into the building. And then you'll see on the bottom right, there's a blue arrow that pushes back, and that's how it's transferred into the ground. Much more complicated than this from an engineering perspective, but I think you all understand that this is what the structural system does and what it's intended to do. It's there so that when the wind blows, the building doesn't fall over. The weight or the load of that wind is transferred into the ground. Now, there's a couple of other things to understand. There's a primary load-bearing system. And the primary load-bearing system is the assemblage of the above-ground structural components within the building that form that path that carries these loads to the ground. Now, the reason I separate them, or I say this, is because there's a difference. There are different types of pieces of the structure in the building. But the primary load-bearing system is what takes the main loads of the building and takes it into the ground, so essentially the building doesn't fall over. But what else do we have? We have a lot of structural components in our building. So just a couple of examples. On the left, we have balconies. A lot of times they're concrete balconies that stick out past the building. On the right, you have wood decks and these type of things. So these are structural components. But if you take the balcony or the decks away, the building isn't going to fall down. Those are just components that are structural, but they're not primary in terms of making sure the loads are transferred into the ground. So what generally happens is that the weight of these balconies are transferred into the primary load-bearing system, which carries it to the ground. But again, if these things are not there, the building won't fall over. The balcony may fall over, the deck may fall over, but the building's not going to fall over, which I'm going to touch on in a few minutes. Also, podium decking, and I'll touch a little on podium decks in a second. but just an understanding of what a structural component is that may not be part of the primary load-bearing system. So what is the structure not designed for? It's not designed for deterioration due to aging. So if you look at the building code, it says you have to design, let's say, for a 100-mile-an-hour wind, but it does not say in there you have to design a building that will last for 100 years. So deterioration for aging is something the building is not designed for, and that's what we're talking about. We're not talking about buildings that are built wrong. We're talking about aging of a building and deterioration of a building as it ages. That doesn't mean that it was built wrong or designed wrong. Keep that in mind, it's very important. So what's the primary cause of this type of deterioration? Obviously, it's age. As things get older, look at me in the screen. As things get older, they start to age and they deteriorate, which I can tell you that it happens in humans too. But the other thing that's very, very important in terms of the rate of the aging and the deterioration is moisture. Water makes things get worse and age faster, essentially. And I'm going to talk about that a fair amount in the presentation. But keep in mind also that a lot of people are under the impression that if a building is next to the ocean, it deteriorates very rapidly. But if it's 1,000 miles from the ocean, you don't have problems with moisture. It's not true. Basically, salt water makes things deteriorate faster, but water makes things deteriorate. So it's not just along the coast, clearly. The other thing I mention all the time is that there's no question that salt in the water will make something deteriorate faster, but you don't only get salt in water that it comes against a building next to the ocean. What about parking garages? That you have cars that come in them in the winter in the north, and they're carrying the snow and the salt from the roads into the parking garage, and that salt is in the water. So it's not just along the coast. Keep that in mind. It's water that does it. And if you take a piece of steel and get it wet, it's going to rust with regular water or with salt water, but it's going to happen. It's just the rate that it happens. The other cause of deterioration is a lack of preventive maintenance, which I have a whole other webinar in terms of maintenance and preventive maintenance, how to do it, what it is, all that kind of stuff. But preventive maintenance will delay deterioration, but generally it does not stop it. It just delays it. But preventive maintenance can extend the rate of deterioration significantly. So those are the primary causes of deterioration: age, moisture, and preventive maintenance. So what protects a building? The thing that protects the building is what's called the building envelope. It's what around the building and keeps the inside of the building from getting wet, essentially, or the wind getting to it, called the building envelope. It's primarily made up of the roof and the facade, which are the sides of the buildings. Now, you'll see that there is another standard for a building envelope, and this is it. It's the guideline for condition assessments of the building envelope. It's also put out by the American Society of Civil Engineers. It's not part of today's presentation. Today, I'm talking about the structure of the building, although you'll see I will touch on the building envelope a little, but it's another standard. It's not a part of this presentation. It's very interesting that when we did our research, we found that there are about, I think it was 13 or 14 cities across the country that require that facade evaluations be done on a regular basis, generally every 5 years or so. And the reason they do facade evaluations, like in New York City, they're local law 11, you have to do a facade inspection. So, but the thing that's interesting, the facade inspection is meant so things on the buildings do not fall on the people that are walking by. But like I said before, there's pretty much nowhere in the country that requires inspections of the structure to make sure it doesn't fall on the people inside of it. But this is another standard. There are, like I said, there are a number of cities that do have facade inspections. We're doing a few of them. And if there's interest, maybe we'll do another webinar like today on a condition assessment of the building envelopes, the facades and the roofs, rather than just the structure. But that's another part of it. Now let's talk a little about some of the materials. And keep in mind when I'm doing this, that if I can figure out how to make it work, I have a quiz about one of these things. So I want you to keep it in mind. But I want to explain to you a little bit about the main materials that are used in buildings and what the problem is with it. The first is concrete. Concrete, what the strength of the concrete is different in two directions. The concrete is comprised of two different materials, essentially. One is concrete, which I'm going to show you some pictures of it. The concrete is very good in compression. What do I mean compression? And if you could see my hands, compression is when you push against something, you push together and it compresses. So it's very strong when it comes to compression, but it's very poor in tension. What does that mean? When you pull concrete apart, it's not strong to keep itself from being pulled apart. So concrete is good in compression, poor in tension. Why do I say that? Because when you have a concrete, as you'll see in the pictures, the concrete has inside of it what's called steel reinforcing. Steel reinforcing, which I'll show some pictures of, very, very good in tension. So in the areas where the concrete beams and columns and things need compression, load, strength, then it's very good for that. But in places where it goes into tension and pulls, there's reinforcing steel put into the concrete because it's very good in tension. So the concrete is made up of two materials. Now, if you look to the left, I want to point out something. Remember, there's going to be a quiz that if you look to the left here, I think you can see, I don't know if you can see my pointer here. I think you can see this pointer. When you put weight on top of a beam, what happens? The bottom goes into tension, the top goes into compression. Remember that because there's a little quiz coming up. So top's compression, the bottom is tension. And then you look over here to the right, you see that the steel reinforcement is put in the bottom of the beam because that's where it goes into tension and the concrete does not have good strength capacity in tension. I will also say that beams generally have steel on the top and the bottom. The top steel is there not so much for strength, but it's to keep it from cracking. But just so you know that it generally does have steel on the top and the bottom, but less in the top. Depending on the design, because sometimes you have tension in the top and the bottom, but there's different things. But I just wanted to point out to you what are the characteristics of concrete, which I'll touch on and again in a few minutes to show you why it's important. Now here in the left, you see a picture. This is a beam. What's happened is this is the reinforcing steel that you see. Water has gotten into the concrete and rusted the steel. What happens to steel? Look down at the bottom. Before the corrosion, it's just a piece of steel embedded in the concrete. Then there's a buildup corrosion products, water. The water gets to the steel, and what starts happening? The surface cracks in the concrete. The steel expands. It expands as it rusts, and it pushes against the concrete, which then puts the concrete into tension, which I mentioned before. The concrete is not good in tension. So as soon as it starts expanding, in some instances, in many instances, you get what's called spalling, where the concrete goes into tension and it pops off because the reinforcing steel is getting wet, rusting, and expanding. Now look at this beam. Pretty obvious what's going on. It's the reinforcing steel is in the bottom. The reinforcing steel, for whatever reason, we'll talk about, got wet. It started expanding. You could see it rusted. And what it did is it expanded and popped out the corner of the steel beam or the concrete beam. And that's very, very common, which I'll talk about, way for deterioration of structural concrete to happen. But it's called the rusting of the steel. But now let's talk about a steel structure. The steel has the same strength in every direction. Very good in tension, very good in compression, but it's the same strength in all directions. So it's not like concrete. We have two different materials and two different strengths. So what causes deterioration of steel? It rusts. Pretty straightforward. These are actual pictures that I've taken of what happens. Now, if you look at this picture here on the right-hand side, this is inside a parking garage. In many, many, many instances, the structural steel is covered by this white stuff. It's called fireproofing. So the steel is covered by the fireproofing. So you really can't see it rusting other than when the fireproofing starts to get wet, and then you start seeing an orange color on the fireproofing, but you don't see the steel below it. So if you look at this picture, what we did is we started to see that the fireproofing was wet, and we start to see signs of rusting. So you peel it off, and on the left, this is the kind of thing you can see that's hidden by the fireproofing. The steel is totally rusted through, and as soon as you get rusting through like this, like what you see, the beam totally loses its strength. So this is an example of common cause of deterioration. Again, with steel, as you would expect, is water. Talk about wood. I'm not going to really focus on this a lot, but wood strength varies. It's a very interesting material. If you have the wood in one direction, which is parallel to the grain, it's good in tension, it's good in compression. But as soon as you start pushing perpendicular to the grain, it's not as strong. And the strength of wood deteriorates significantly if it has moisture that gets into it or it has high temperatures. I've had the pleasure, because I love to design stuff, of getting involved with a lot of wood design in my career, especially wood cooling towers that are wet, they're high temperatures, and you get involved in designing it based on different loads in different directions, all kinds of things. And that's one of the things that makes wood an interesting material. But there are a number of things like water that can deteriorate it significantly. So here's some examples of what wood looks like. A bottom picture of what happens when wood gets wet, it deteriorates. Now clearly it loses its structural capacity when it starts rotting away, essentially. The top picture here is actually a project we're working on right now where the wood trusses in the roof are built in 1927, and just based on aging and in some places water getting to it, they're significantly deflecting to the point where when I saw this, we put in temporary shoring for this within a day because it looked like it was about to collapse. And right now we just finished the design and started construction to rebuild this entirely so it's structurally sound again. But a common cause of deterioration is aging and moisture. Now let's talk about a podium deck, one of my favorite things. A lot of us have buildings, and I'll give a couple of examples as part of the presentation, where there's a deck at the bottom here that can support the buildings. And a lot of times you have recreational areas above the podium deck. You have parking below the podium deck, as you can see from my arrow. Very common type of construction. So what holds up the buildings and the podium deck? You have the primary structure underneath, the primary structural system, which then goes up into the buildings. And you also have structural components that I talked about before. The reason for the podium deck is it transfers the load, for example, from this upper building into the foundation and into the ground. So the podium deck is not only structural, but it also supports areas where you may have trees and plantings and recreational areas and buildings. But podium decks are something where it's very common that you can see problems in it, such as this. This is an example of a multi-level parking garage that's a podium deck below. So what do you see on the top? You see deterioration. Let me check my time. Deterioration of the deck because of the salt water or regular water coming in, dragged in, brought in from the cars, and it sits on this deck. Many instances, these decks have membranes that are put on them or waterproofing, but which goes into the reserve study. So here's a connection, which I'll touch on again later. But if you don't reserve for a membrane on top of this type of deck and do it and install it, the water is going to get into this concrete and start rusting the steel, so like you see in this picture. The other very common problem with podium decks is that they're very large open areas. They have what are called expansion joints. Expansion joints allows the concrete to expand and contract. As the temperatures go up and down, materials expand and contract. If there's too much of a length of a piece of material and you don't have an expansion joint, it may start cracking the material and it will create its own expansion joint. So designs for something like this typically include expansion joints, which allow it to move, but also there's usually a piece of plastic on something on top to keep the water from getting through. In this case, what we see is the water gets directly through, but what's underneath it? You look to the right-hand picture, there are steel beams that are supporting that podium deck that because the water is getting through is rusted away. Now, this is something I'll touch on later, but here's a perfect example of the connection between reserves, maintenance, and the primary structure, and why all three of them are important, because they all affect each other and they can have a detrimental effect on the underlying structure. All right, the one I just showed you was this is a podium deck. The prior slide is a podium deck with a parking garage, and where to go. Parking garage. This one is a podium deck that has a driveway up above, and there's all kinds of recreational areas. And again, you can see these are the expansion joints. There's a lot of them. Most of them have failed. They haven't been fixed. And then what do you see underneath? In this case, it's concrete. And look at the crack in this concrete from water getting to it. To the right, I'll touch on this again later, but look what they do. What do you want to do? You want to keep the water from getting onto the cars. You don't care if it cracks the concrete or the steel. So they put in a gutter to collect the water and a downspout to bring the water down to the ground without taking any note of what's going on with the structure above it, which I'll touch on in a little while also. Brick facade. A brick facade, I'm going to just show you a couple examples. The brick facade is made up of brick. The water is supposed to get behind it and have a way out. If the water doesn't have a way out, it can rust the lintels at the bottom, causing them to fail if it's not, if the water can't drain properly. In this picture on the right, there may not be an appropriate number of brick ties, or the water got behind the brick and rusted the brick ties, and some of the brick can fall off the building. This is more related to the building envelope evaluation than the primary structure, but I wanted to throw in that picture. When it comes to safety for building, it starts when the building is being built. Proper construction and planning is very important for the safety of the future safety of the building. This has nothing, again, to do with if the building was designed right and built right or wrong. But what happens in structures and buildings when you build them? Nothing ever matches the drawings exactly. So the purpose of these legislation and the public policy recommendation is that if the structure is being built and there's a change from what the drawing shows, even though it may be okay, there has to be a letter from a licensed engineer to verify the structural adequacy if it's not built in conformance with the design drawings. So building safety and long-term viability from a structural perspective starts during construction. And a lot of the legislation now says that if there's a change in the structure and there's not a letter saying that the structure is adequate, then a certificate of occupancy won't be issued until that type of letter or confirmation is issued. But what we're primarily concerned is the process after construction. This process includes periodic assessments, starting with a preliminary assessment, followed by a detailed assessment if required. So this is what I'm going to touch on and show you some examples of what they look like and what they are. But the periodic inspection of the structural system is inspection aimed at identifying issues with the structural system when they become evident. And again, deterioration of the structural system can occur over time, but it does occur over time due to deterioration, wear and tear, poor maintenance, and water. It's a progressive condition, which not typically, but does worsen over time. And that's what we're talking about. I don't really talk about timing of periodic inspections in this presentation, but just very briefly, most of the legislation says that for buildings, once the legislation is passed, all buildings that fall into this category that I talked about will need to be inspected within a few years. Worst case, or some places it says within the next 2 years, others later than that, but all buildings of this type of material of construction will require inspection. And then after that, the general rule of thumb is that for buildings that are up to 20 years old, they have to be inspected a maximum of every 10 years, and for buildings over 20 years old, every 5 years, because the deterioration occurs more progressively and faster as building gets older. Now, I'm not going to get into where that came from, but that's just a general guide because I'm kind of anticipating that question. Who does the inspection? The inspection is done by a professional engineer. And here's what it says. All personnel involved in the assessment shall possess the technical qualifications, including practical experience, education, and professional judgment required to perform the individual technical tasks assigned. Very important last sentence. Interpretation of the results and conclusions shall be performed by a registered professional engineer qualified in the appropriate discipline. So what this means is that it doesn't have to be a licensed engineer who does the inspections and identifies different conditions, but in terms of evaluating what those conditions are and the effect on the structure, it's very, very important that it be done by, and it's required in every discipline, in every location I've seen, it's required that this be done by a licensed professional engineer. The one thing to keep in mind, which I'm going to say again later, is that just because a structural engineer knows how to design a new building does not mean that they know how to look at an existing building to see what kind of problems there are and how to fix them. It's a special art. I will tell you that in college, I'm not aware of any college of engineering schools that teach you how to design a repair to a building. They all specialize on how to design a new building. So it's really an art, and there are plenty of people that are qualified to do this, but just because somebody says they're a structural engineer doesn't mean they have the qualifications to do this. Now, here's the quiz. I do have a quiz with a poll, but I don't really have time to do it. So I'm just going to point out concrete quiz. You can see the rust. So why an engineer? Now you look at this. This is exactly from the other slide. Keep in mind that concrete is good in compression, poor in tension. Reinforcing steel is good in tension. So I'm going to give you the answer, but I'm going to show you why you need an engineer to evaluate the results, even though they don't identify where the conditions are. What is the worst place to see rust? All right, now the key to this is the top of this beam is in compression, the bottom is in tension. So if it's rusting on the top of the beam, is that worse than at the bottom of the beam, or are they both the same? The answer to the question, I hope you all got this, is pretty clear that the concrete is not good in tension. the reinforcing steel is needed to provide the strength you need in tension. So if the beam in this case is rusting at the bottom, that means the reinforcing steel in the bottom is rusting, and that means there's no tension capacity in that beam, and it can create a structural problem. I may be talking a little too much engineering terms, but I think you guys get it. But then if you have the steel in the top where it's in compression and that rusts, keep in mind the concrete is very good in compression. So there's not as much of a concern from a safety perspective. But also I'll add a little asterisk to that. And like I said, there is reinforcing steel in the top of the beams also. But if that steel in the top rusts, expands, and pops out or spalls the concrete in the top, then you have less concrete to absorb the loads in compression. So it can create a problem also. So that's why an engineer is needed to look at this to evaluate what is the impact of the deterioration you're seeing on the structural capacity of the beams, the columns, and whatever they're looking at. So that's why I just want to put this slide in there to show you the importance of having a structural engineer, although I'll touch on in a few minutes what managers can look at, but this is the importance of structural engineer. Now let's talk about the few different types of assessment. Preliminary assessment is essentially looking at the structure. Here it goes. Preliminary assessment provides the initial data for estimating the structural adequacy of an existing building and for establishing the need and priority for more detailed analysis. Now, it includes looking at documents, inspection, and analysis. And I'll show you some examples of this. But the preliminary inspection is something that is generally done in order to take a view of the entire structure to see if there's any potentials for problems. That's preliminary. Now, I added in here a baseline. This baseline assessment is essentially the first preliminary evaluation you do. And the reason I put in here a baseline assessment is because I talked about before that buildings have progressive deterioration. So what do you measure it against? You measure it against the first assessment that's done, which is the baseline, because it establishes the baseline for future deterioration, so you can measure it against it. Now, it's very important, as you can see, that once you have your baseline assessment done, you need to keep that in your files and your records, because the next time you do your inspection, let's say it's 5 years later, 3 years later, whatever it is, you need to look back at that baseline assessment to determine if there's progressive deterioration. Also keep in mind is once you do your next inspection, that then becomes the baseline for the next inspection. So the baseline inspection is the initial one, and essentially all of them are baseline inspections because they're used for the next inspection and they establish your baseline for structural deterioration. So baseline assessment. Now, a detailed assessment is if you do the preliminary assessment and you see there's a problem, and I'll show you some examples, you see there's a problem, then you're going to do a detailed assessment to determine how bad the problem is, does it affect the safety of the building, what should you do, how long does it take to fix it, and what exactly should you do. So you're not doing a detailed assessment of the entire building and the entire structure, you're doing a detailed assessment in the areas where you see potential problems. So now let's take a look at what's included in evaluation. Now I'm going to show you some actual pages for some reports that we have done. And of course, this is a promotional presentation, but this is the information that should be included in reports like this. So the evaluation includes table of contents. And for each of these items in the table of contents, I'm going to go through and show you what it means and show you what's included. So the first one is the introduction. The introduction has a description of the structure, which includes the type of building, the materials that are used. For example, this is the description of the structure from an evaluation we've done of a concrete building. Now, these diagrams in here are essentially in the beginning of the report explaining to the client, how does the concrete work, the importance of the reinforcing steel, and what it looks like. So this is the description of the structure. The description of the structure also goes on and shows for that existing building, for example, here you're looking at a concrete building and you have concrete beams, concrete columns, and it identifies from the actual building what the structure is made up of. And then on the top, this is some details from the actual structural drawings of that building, showing how the size of these beams, the size of the columns, the type of reinforcing that should be in them. But this is part of the description of the structure. And don't worry, in many cases, you do not have these drawings. You're only basing it on what you see. And I'll show you a kind of a problem with that type of thing. But it's very important. If you have the drawings, you have to review them and you have to do a comparison. in terms of your description of the structure. Now, here you go up into a high-rise building, and this is taken by a drone. Now, this is showing description of the structure. This is a concrete balcony that sticks out from the units, and these are concrete eyebrows. If you don't know the terminology for eyebrow other than this eyebrow, an eyebrow is essentially the concrete floor that supports the building and extends all the way across the building, and then it sticks out around the perimeter of the building. And the term for that, like you've seen this picture, is a concrete eyebrow. So this is part of the description of the structure. Now let's talk about, the next is how you do your investigation. Part of that is meetings and site visits. So meetings and site visits, the meetings are to determine and to be pointed out any potential areas of concern from the manager or the building owner, but also then that's where you put together your plan to look at the building. Now in this case, I'm showing you, this is from an evaluation we did of a parking garage. And what we're showing is the course of the inspection. I'll show you why in a minute, but we start here and we wrap around the parking garage following the arrows, and this is how we do our inspection. This over here, where the pointer is, it's actually a ramp, and I'm going to show you a problem, but this shows the course and how we did the inspection. So that's it for, in this case, we're in a plan looking down a parking garage. Now, in many cases, we're doing inspections of the exterior of the building. And I'll show you some examples, but we typically do those with drones, and people use drones rather than dropping lifts and things like these. Drone gives you great information, but here's an example of a drone evaluation of how we did the review of the facade of the buildings. Here's where we started. The drone went back and forth all the way up and down the building and evaluated the structure all the way up and down by going back and forth. But this shows you how we actually did the evaluation and how we got our documentation. Doesn't mean that based on what we saw, we didn't go back into some of the units to look at the balconies, but the views that I'm talking about now are the first step in determining what the next steps are going to be. Next thing is to review documentation. Obviously, all design documents. I just showed you any drawings that you have. It's very important. We'd love to take a look at it. Very important. Historical information, any information in terms of problems that you see with the building you feel should be looked at or provided by management or the owner. All of this information is included in the report. So, for example, this is an example of the documents reviewed section of this report where it lists every single drawing that we looked at. Keep in mind the top one is for detailed evaluations, as well as for follow-up preliminary evaluations. You should have all prior reports to look at for progressive deterioration. So these reports are very important to keep as documentation for future inspections. But when you're doing your inspection, you should look at the drawings, be provided with any type of historical information, as well as be given any prior reports that were done, whether large or small, that identify prior conditions. This should all be detailed within the report, not just a listing like this, but also a description of what you were given and what the contents that told you. Next is there's a findings section of the report. What do you put in the report? How do you identify problems? And what are the descriptions? For example, this is what we typically use, and this is in our findings, the beginning of the report. The rating system used extensively throughout the report, and we identify things as being severe, moderate, or minor. The recommendation or the description is, let's start with minor. Visual observation of conditions which are indicative of progressive deterioration, but does not require immediate action. Areas should be re-inspected within 3 years. Now, the number of years before re-inspection change based on the conditions, but as I mentioned before, if you go to a building that's less than 20 years old, the general guideline is it should be inspected a maximum every 10 years. Based on the conditions we saw in this building, we're recommending 3 years, but and that's why I say that, because keep in mind, maximum of 10 years, maximum of 5 years after the building's 20 years old, but the report should give you more guidance based on the actual conditions. So here, minor means we inspect within 3 years. Moderate means the conditions are indicative of rapid progressive deterioration. So that means requires a secondary periodic inspection within 12 months to evaluate rate the progressive deterioration. Now, here's the worst one. The question comes up. Severe. It means deterioration of visually observable structural concrete members in this case, which is indicative of potential for strength reduction and possible inadequacy based on the applied loads, which means, in summary, fix it now. So it requires a detailed assessment and remediation in the immediate future. So any report you get should identify the locations and give a rating in each of those locations. Now, let me show you how that's done. Generally, the first thing that's done is to give a description in the building of typical conditions. For example, in this summary, in this report, it says parking garage. Typical conditions include minor crack in slab, moderate crack in garage slab. So it gives you typical conditions. This is cracking. Next one is efflorescence. Here you see efflorescence. Efflorescence means you see a white substance, which means that water is going through the concrete and carrying the salts through it. So that means water is going through it and can come into contact with the reinforcing steel. And one of the first signs of that's efflorescence. So this is typical conditions that we saw: moderate efflorescence, severe efflorescence. Generally, severe efflorescence means that you see some signs of rust, not just of salt. So that's a couple of general conditions that we saw. This is another one. It says scaling, where the surface of the concrete is peeling. Here's minor scaling. Here's severe scaling. And I'll tell you that also in that ASCE guide for structural evaluations of existing buildings, it gives you definitions of the types of conditions and the severity of the conditions. So there's some great reference material included in that ASCE guide. And that's what we use here in determining minor scaling, severe scaling, but also keep in mind engineering judgment in terms of, or engineering knowledge in terms of how that can impact the structure. Now, the next thing is very, very important, is where are the locations of what you see? And it's very important that the report identify the conditions and the specific locations. So what you're looking at now is, this is a plan of a building that we did. This is from the drawings. There are many, many structural concrete columns. Now you see this red designation here? That is for location. I can't see it, but maybe location column number 40. So you'll go through this report that we did and you'll see this plan. This red designation changes each of the different columns. And then for each columns, we've taken a picture and documented all 4 sides of the column and the condition of that column. So this is, in this case, this building has now gone through, based on a report, and we prepared a spec to totally redo the exterior of the building and any concrete problems. The building wasn't going to collapse. It wasn't close to collapse, but there's progressive deterioration. And they decided to invest the money to redo the entire exterior of the building and all of the concrete exposed columns so that they can reduce significantly the rate of deterioration that's occurring based on what we saw. So, which I'll touch on what cost of doing this stuff in a second. But this is one example of showing the location and the specific condition of everything. Here's another one, the same building, but now we're going to the outside up above the building. So here you can see these pictures are taken from drones. This is the eyebrow, the balconies. These plans show in red exactly where the pictures are taken, and that reflects this location and that condition. Keep in mind, it's very, very important with this type of thing. As I mentioned before, that when we do a drone evaluation, you can see the detail that you get by doing a drone evaluation. Now, if we see something that looks like it's in bad shape, for example, and we need to go back and look at it and touch it and feel it, then you can either do it from the balcony or do it from scaffolding or a lift. But by doing it this way, you don't have to scaffold or lift the entire facade of the building. You drone it, you evaluate what's there, and then you make a determination of what the next step is in terms of evaluating its impact on the structural capacity of the building. The droning saves a significant amount of money, and the pictures that you get and the information you get are spectacular, as you can see here. Here's another building. This is another high-rise, same type of thing. I'm showing here on the right-hand side is the elevation of the building, and it's circled in red, the exact locations. And then here you look at the drone picture, and it's also showing the exact same location, so you can see exactly and identify the conditions in these locations. And you'd be surprised if you zoom in on these drone pictures, you can see cracks in concrete, you can see all kinds of things that are, it's amazing clarity and detail that you can see. But this is also included in the report because it has to identify all the locations and the condition of each location. So this is how it should be tracked. Now we get into the detailed specific locations of problems. Now, in this case, on the left, I'm showing what the conditions are, which I showed you the definitions before, but this is the parking garage I talked about before. We showed a plan and we showed how by the arrows somebody's going to walk through and look at the different conditions. So here's what we're showing is parking column number A158, structural member, it's the ceiling. What's the deficiency? It's cracking, severity minor, and a remark at the pipe hanger connections and throughout the area. So now what we do is we show exactly where that location is. We show a picture standing back and looking at it and a close-up of the picture so you can see it. This should be included in the report, very specific details of every single location and what you saw. So this is a case where it's minor deterioration. I'm going to show you an example of the different types. Now here's moderate, exact same thing, description. Now we have the plan of the garage. I'm running out of time here. Scaling with exposed rebar. As soon as you have exposed rebar, you get concerned because that means it must be rusting and popping out the concrete. This is moderate. It's on the ceiling by the back wall. Now let's get into a severe condition. Look at this. Ceiling, deteriorated concrete with exposed rebar and rust. It's severe. You can see what's going on here in the close-ups. Exact location, where it's happening. It needs to be fixed. I don't need to say more about that. Now, here's another severe thing, which I see a lot of, which really, it's kind of scary, is that people go into the garages, and if there's a structural problem, so the concrete doesn't fall, they'll put in some kind of netting or something because they know it's rusting and they know they have problems, but they don't want it to fall on the cars. This I consider a severe condition because we can't see it, but clearly something's going on behind here that somebody's hiding to protect the cars below. Don't do this. Now let's look at something, and this is a parking garage we're in where this is a severe condition, where this beam that you're looking at right here on the right, severe deterioration at support beam. This beam is at a ramp in the parking garage. Contained within that beam is a trench drain because the ramp slopes down, there's a beam supporting it at the bottom, and there's a trench drain to catch the water. So what happens over time? The trench drain doesn't hold the water, it gets into the concrete, and this is what happens. Severe deterioration at support beam, severe deterioration, but this is an actual beam. So this is a severe condition requiring immediate action. Some of the things that happened here, just to show you, is this is temporary shoring. We did a design for temporary shoring to support this area while the more detailed evaluation is being done so that the final design for fixing the beam, which is this, you come up with so that it can be fixed. But in this case, based on the condition, there's temporary shoring, and that's the remediation design to fix it. Some additional evaluation techniques I want to point out, which we use all the time, are drones, which I showed you before. Drones are a huge tool. Thermographic evaluation. Here what we're doing is we take a thermographic camera, which can tell the temperature of the facade, and you do it right time of day. And then by doing this thermographic evaluation, you can see where water buildup is. Look at this bottom picture. You see where it is? It's right here. And what's going on? You see that brightness? That means it's much warmer there, which means that what's happening is the water gets in there during the day. It heats up behind the brick. Then as the air starts cooling, you take a thermographic picture. The water holds the moisture and the temperature. The water holds the moisture. The water holds the temperature. So it jumps out that this is where you've got a leak in this top parapet cap. So thermographic evaluation. The next one I'm going to show you, this is called non-destructive imaging. Now, this is something where you actually do imaging of the concrete, and it can tell you a few different things. It can tell you if there's rust on the concrete. It can tell you if the concrete is expanding, which means that the rust is expanding the concrete, and it tells you a few different things. This is, to be quite honest, this is something that came from a report that somebody I know who lives in a high-rise in Florida has done this kind of non-destructive imaging, and I wanted to show it because this is something, a way you can look at it and start seeing if there's potential damage occurring even before you start seeing cracks in the concrete. So this is called non-destructive imaging. Now, how do the other pillars connect? Reserves and maintenance. And I went into a little, first of all, reserve study, it's a budget planning tool to replace the common elements as they replace. You all know that. You've probably listened to 50 of my presentations about that mid-board to death. So you know what a reserve study is. Keep in mind that a reserve study does not include a structural review. It includes an inspection. Also, RSs are the reserve specialists, the reserve schedules. Only about 50% of them are engineers. And I would say very, very few of them are engineers that are structural, that can identify and come up with plans for problems. So don't rely on a reserve study. They're not a safety audit, an architecture and engineering study. And so that's what they're not. They are not structural. That's why they're one part of the puzzle. The other part of the puzzle is maintenance. Maintenance, there's three types of maintenance. Preventive maintenance, something you can plan and do, such as putting, like this building, high rise I told you, they're doing preventive maintenance. They're putting a coating on all of the concrete in that building to prevent proactively water from getting into the cracks and getting to the reinforcing steel. Preventive maintenance. Corrective maintenance is after you do the periodic inspection and you see damage, you go back to correct it. That's corrective maintenance. And then there's deferred maintenance. Deferred maintenance is exactly what it sounds. The term is used incorrectly in the industry, including by me in my office sometimes. But deferred maintenance is not preventive maintenance. Deferred maintenance means you're not doing it. So what we get involved in is preventive maintenance proactively, corrective maintenance when you see a problem. Then how are they all connected? I mentioned this before as a podium deck. Here's a podium deck. The structure of the podium deck is protected. The structure is protected by the podium deck above, right here. The podium membrane and decking are included in a preventive maintenance program. When you see it leaking, fix it. And then the podium membrane and decking are also included in the reserve study, so you can see how everything is connected here. Now, people panic about the cost of these things. I want to show this slide because if you take a look at the cost of preventive maintenance, generally it's about 5% of the replacement costs that are spread out over the life of the component, general rule of thumb. But if you don't do preventive maintenance and you have to do corrective maintenance, it can cost significantly more than the total cost of the preventive maintenance you've done over the years. As one study that you can see here says that it costs 30 times more at least than the cumulative cost of preventive maintenance. So from a life cycle perspective, do preventive maintenance. Don't wait until you need to do corrective maintenance because it will cost a lot more money. So that's life cycle cost. Now, manager's role. If you're a manager and older, if you identify signs of deterioration, have an experienced engineer evaluate the impact of the condition on structural adequacy. Do not allow conditions to be concealed. I see so much of this, and I'm going to show you a few pictures of the things I see every day. And I promise you, based on what's going on in the world right now, and even what's going on before, if a manager or building owner allows this type of thing to happen, and then there's a problem, there's risks involved. I'll leave it at that. And again, here, you see an example. To the left, I love this picture because the left, you're seeing efflorescence, which means the water's coming through. Right next to it, you're seeing what happens next. That water attacks the reinforcing steel and it rusts. So some of the things you see, if you see something, do something in steel, rust, or moisture. If you see moisture, stop it because it'll stop the rusting. Concrete, if you see cracking, efflorescence, rust stains, moisture, wood deterioration, moisture. But I love this picture because it shows you phase 1 and phase 2 of progressive deterioration. We talked about drawings. Do you need drawings? The important in drawings here is in this column, we saw that it was rusting. We saw rust, but we did not have the drawings. We assumed that it was a reinforced concrete column, but when we took it apart without the drawings, we found out there's actually a structural steel column encased in the concrete, and it's not a reinforced concrete column. So that's the importance of the drawings because you know what the structure is. But here, we saw rusting, we stopped it, we find out if there's any damage, and we fixed it. Obviously, we found damage. Now, here's some other things. What to watch for and not do. Some real-life examples here. What they did is there's cracking here where water's coming through. They're getting rusting and reinforcing. It looks like a gutter was put in to carry the water to a downspout. Now you really can't see what's going on. Same thing, what to watch for. Look at this, bottom left. There's cracking of the concrete, exposed reinforcing steel. So what they do, they didn't fix it. They put it in a net so it doesn't fall in the car. Here's another one, very common. Blue tarps to divert the water away from cars so that the beams and everything can structurally fall apart, but the cars don't get wet. Here's another one, typical. Get the water away from the cars. This is one of my favorites. Brand new building. This is what a typical joint looks like to the podium deck above. You can see moisture coming through slightly. On this one to the left, it's right next to this one. Look what they did. And this was done by the builder in this case, but they put in a gutter that runs all the way across with downspouts. We have no idea what's going on in here. So another thing you should not allow to happen. And here, look at this. On the right, what they did is they put in a diverter because there was water coming through a joint. They diverted the water away from the cars, but now it's running directly against this steel beam. When we peeled off this fireproofing, the steel in this area, the concentration of rust is right here. So this is what fireproofing looks like when water gets behind it and steel starts to rust. It's wet and then it turns brown. But look what's happening. They've directed the water directly here. Here's a condition to the left. If you see something like this, you got a problem coming. The water coming through, you got stalactites or stalagmites, whatever it is. You see efflorescence everywhere, and you see water and staining of the steel beam on the side. So what do you do when you prepare for an RFP? If you want an engineer, you want to get proposals to do this, provide a description of the building and the bidding requirements. You know, the type and age of the building. Has it ever been inspected before? If it has, provide a copy. Require a site visit. Have the engineer come out to look at the building before they give a proposal. Request qualifications. It's not the same as designing a new building. They have to have qualifications in terms of an existing building and bonds. Do an interview. If you do an interview with somebody, you'll feel much more comfortable. Ask for an example report to take a look. Don't make the decision on dollars alone. I saw one recently where the person gave a proposal and they told me that the proposal was like a couple, maybe $1,000 less than ours. And they decided to go with somebody else. Then after they got the report, they couldn't believe it. And I'm actually going to that site tomorrow to take a look because don't make a decision based on dollars alone. But keep in mind, if you have an RFP, like I'm talking about, you can get apples to apples proposals as opposed to just saying to somebody, I want a structural evaluation. Take a look into any local requirements, such as Jersey City has it for structures and facades, Hackensack has it for parking garages. Make sure that the report includes a rating system, that all conditions are identified with the location based on the plans and elevations, photos, and a description for every single location. That the inspection report includes all observable structural elements, not just the primary load-bearing system, but also any structural components like concrete balconies and these type of things. And even if it's in good condition, if it's the first report, pay a few dollars more to have everything documented so you can use it as a baseline in the future to see if there's any progressive deterioration. And then any areas require more evaluations. What I'm talking about is a lot of times, in a lot of places, you cannot see the structure. But if you see settlement starting to occur, but you can't see the structure, it should recommend taking it apart to see why you're having settlement. If you see water in a wall in a building and it's wet and there's a structure behind it, and if you see rusting especially, you need to take that ceiling or wall apart to see what's going on behind it. So the report should not only identify conditions that you can see, but identify locations where it should be open so you can see something else that may be underneath it. Now, I just wanted to show you that this is Jersey City. This is the ordinance of Jersey City that came out as a result of what happened in Florida. Structural inspections are required every 10 years. Facade inspections are every 5 years. The thing in here, it says for the structural inspections, it's for buildings 6 stories or higher made out of concrete. For facades, it's for buildings up to over even less than 6 stories and every 5 years. So I'm not going to comment on my feelings in regards to what the requirements are, but Jersey City has very specific requirements, and Hackensack also has specific requirements in terms of any below ground parking garages have to be inspected every 5 years because there's a collapse of one of their parking garages. I will tell you that also in New York City, they instituted a requirement for parking garage inspections also, which is in place now, and you're seeing more and more of this across the country. So with all that said, a lot of information. I see people are still here, and I can go back to you guys. So I hope I answered any question you guys have. Feel free to jump in, unmute yourself, or send me an email, and we'll send everybody a copy of this presentation. But I hope that you found this of value. And if you have any other requests for any types of webinars or anything, please feel free to let us know. As you can tell, we love to do this. But does anybody have any questions now you want to jump in or ask or put in the chat room? I can now see the chat room. Not one question? Boy, I touched on all of it, huh? All right, well, if anybody does have any questions about their buildings or what you're doing, please feel free to send me an email. If you'd like to send an email with a picture of something, I'll take a look at it and comment on it for you if you like. I mean, it's not the same as going out to look at it. And obviously, I'll put a disclaimer on the bottom. But if you have anything that come up that you have any questions or anything about, please feel free to send it to us. And we will send you a copy of this presentation. And again, if anybody has any questions, please feel free to reach out to us. And I went 5 minutes over. I apologize, but there, as you can tell, there was a huge amount of information. So thank you very much, everybody, for attending. Have a great day. And where I am, it's raining. So get your umbrella and don't let your buildings get touched by that water. So, all right. Have a great day, everybody. Thank you very much. Mike Flippin, go comb your hair.
Thank you.
Bye.
Haircut day.
Thank you. Thank you, Mitch.
All right. Thank you, everybody. Take care.